We pulled the launcher back to the bottom of the E, which was consistent with using the maximum force, which is 100 newtons.
Alex and Rachel placed their foot on the hurdle to keep it in a consistent spot.
Here's our setup. We used the red hurdle every time to keep things consistent.
We hooked the launcher handles to the top of the hurdle to allow for consistency with every launch.
We counted the holes to allow for the same height with every launch. It was exactly 1 meter.
We took before and during our trial launches.
1. Obtain hurdle and place it on the highest setting. 2. Wrap launcher around the top of the hurdle. 3. Start at 45 degrees. 4. Pull back with maximum force, 100 newtons. 5. Place tennis ball in the launcher. 6. Start timer when the launcher released. 7. End timer when the ball hits the ground. 8. Measure the distance the ball traveled. 9. Record time and distance into chart. 10. Repeat this and change the angle downward, 5 degrees every time until you get to 0.
After we did the trials, we created a chart that allowed us to organize our work. Notice the initial velocity is missing.
We used this formula to solve for initial velocity. Velocity equals distance over time. Here's an example using 45 degrees.
After using the equation, we completed the chart. This chart will allow us to double check before launching for the actual test.
On the final day, we were tasked with hitting the 25-meter mark. Here are the steps we took in order to hit the 25-meter mark. Take all of the velocities collected on the chart, add them together, and get the average initial velocity. Plug the velocity and final distance into the formula above. Get the angle needed to hit the 25-meter mark. Here's how we got the formula to calculate the degree that we needed to set the angle to. When we plugged the numbers in, we got 8.394.